4.2, transversals and parallel lines. And this one's actually really important because this will lay the foundation for a lot of our future understanding, for example, proofs, and a lot of our geometric properties with even triangles and stuff like that. So this one's important. Make sure you watch the whole thing, take really good notes, encourage your friends to take notes. That being said, you're here, which is great. Okay, so first we need to talk about what a transversal is. Most of you guys know what parallel lines are, but we need to talk about a transversal. And a transversal is anything that cuts through two other lines. So that means if we have line P and line Q here, the line that cuts through two other lines is line T. So this is a transversal. Note that the transversal doesn't have to be through two parallel lines. So that's why we specify it as parallel. The definition of transversal just means it cuts through two other lines. And then we have a whole bunch of angles here. These numbers represent angles. So this is angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8. The order may be different in other problems, just warning. Okay, a couple reminders about parallel lines. Parallel lines, you guys are pretty good on. Just a reminder, they're all in the same plane. We can write them with this little parallel sign, which is basically like a little, I don't know, railroad tracks, or just two little mini parallel lines. A lot of our symbols here are just like miniature versions of what we're trying to show. So in this case, we'll put two little parallel segments. And this says that L is parallel to M. And we can denote that with these little carets here. So if we were to mark it ourselves, we just mark little carets. And that shows anything with that caret that looks like they go in the same direction do. So cool. We know that those are parallel. So there's our definition of a transversal and two lines. For this section, remember the lines don't have to be parallel, but we have a whole bunch of definitions to go through. So the first one is a corresponding angle. So remember how before when we had like a triangle, like here's my triangle, right? And I had a congruent triangle over here, whatever. And I'm like, oh, this is the corresponding angle to this corresponding angle here. We have kind of the same thing, except instead of being a triangle, you can think of this as two intersections, right? I have the top intersection and I have the bottom intersection, right? And so I can kind of put these together and be like, oh, I have two lines here cut by a transversal. And so that means that the upper left corner angle corresponds with this upper left corner angle. You know, the upper right corner angle corresponds with this one. The bottom right corresponds with this one. It's purple. This corresponds with this one. So for example, what are some ones over here? Well, it would be like 1 and 5, 2 and 6, 3 and 7, 4 and 8. Those are our examples. There we go. An extra copy. 1 and 5 is a good example there. Same side interior angles. So this one, we're just going to go on the description here. So same side interior angles. So they have to be on the same side. The way this is oriented, we can think left and right, up and down, or left and right. And they have to be the interior. So think about these ones are on the the exterior, right? So 1 and 2, 8 and 7, those are kind of like on the outside, right? Whereas 4, 3, 5, and 6, these are on the interior. They're bounded by these two lines that might be parallel. So these are our guys on the interior. And which ones are on the same side? Well, we have two pairs that are same side, right? We have 4 and 5, and we have 3 and 6. So those are two examples of same side interior angles. And then we have alternate interior angles. So alternate meaning like switching, right? So we're going to switch sides. We're going to go from the left side to the right side, but we're going to stay on the interior here. Again, by interior, I mean between our two lines, P and Q here. So that's these numbers here, interior. These ones are going to be exterior. So just keep that in mind. No, do not fill. Okay. So what are alternate interior angles? Well, they're on alternate sides. So that would be this angle here and this angle here, 4 and 6. The other example is 5 and 3. And then finally, the last set that we need to know about is alternate exterior angles. We'll practice and quiz each other on this later, but for now we just need to go over this. Alternate exterior angles, those are the exterior ones, right? So they're going to be like this one, these ones, and these ones, but it says alternate. So they need to be on opposite sides, and as it turns out, they also are on opposite sides of the two other lines as well. So, for example, 8 and 2 would be a pair, and 1 and 7 would be a pair. So those are alternate exterior angles. Again, just definitions. Let's just keep those in mind moving forward. Okay, so this brings us to the specific case of if we are cutting parallel lines with a transversal. So from now on, we're just going to deal with the fact that we have parallel lines being cut by a transversal. And that brings us to the same side interior angle postulate. And this postulate states the following. It says if two parallel lines are cut by a transversal, so here's our parallel lines, P and Q, and here's our transversal T. It says then pairs of same side interior angles. So let me mark a pair. Same side interior angles, let's try 4 and 5. So there's 4, there's 5. It says they are supplementary. And what does supplementary mean again? Hopefully by now you know that a supplementary means that if I were to add those together, so I'm going to write angle 4 plus angle 5, that equals what? How many degrees? 180. 180 degrees. And we can look at this and be like, oh, okay, I guess that makes sense. You know, this one's a little under 90, this one's a little over 90, so they probably add up to 180. This is pretty cool because we don't have to prove this. There is no proof to this one because it's a postulate. We can just accept it and move on with our life. That being said, we should practice a little bit. So here's the one we're going to use. Is this a separate picture? No. Okay. So we're going to use this diagram here. It's 1, 2, 3, 4, 5, 6, 7, 8 like this. And I got some questions for you guys. What are two pairs of same side interior angles? So think about that for a sec. Write down your answer. I guess we'll pause. It's notebook. We have 4 and 5, which I already mentioned, and then the other pair is 3 and 6. Right? Those are the same side interior angles. There's no other pairs, no other combinations. What is going on? I didn't do it. I don't know why I did that. That was weird. Okay, there we go. So what does this postulate tell us specifically about these ones here? Well, it means that, say, angle 4 plus angle 5 should equal 180 degrees, right? They should be supplementary. I can get more specific too. I can say, okay, well, let's say angle 4 here. I can say the measure of angle 4 is equal to angle 4 is equal to, say, 70 degrees. So if the measure of angle 4, that's about it, is equal to 70 degrees, what is the measure of angle 5? Well, hopefully that's enough information for you to figure it out, right? Most of you can just jump straight to the answer, but for those who can't, remember they need to add together to be 180. We can plug 4 in here, or 70 degrees in here for 4, and then we just have an algebra problem we solve for 5. So 180 minus 70 is 110 degrees. Cool. Hopefully we're good on that, because we're moving on. Those were the answers for A, B, C, and D here, by the way. We're moving on to the alternate interior angles theorem. And the alternate interior angles theorem states, if two parallel lines are cut by a transversal, sound familiar? Same deal. Then the pairs of alternate interior angles, let me go back to our picture here, maybe this one. Alternate interior angles, right? Alternate interior angles, I'll do an example. alternate interior angles, say like 3 and 5, right? If that's true, then alternate interior angles have the same measure. Anytime they give us a theorem, the hair on the back of your neck should start to prickle, because if it's a theorem, we cannot just blatantly accept it as true. We need to prove it. So we're going to prove it because theorems need evidence. They're not postulates, they're theorems. The postulates can be proven, but really in weird, complex ways, and we won't go into those. But these theorems we can do. So let's go ahead and try and prove this. Here in example 1, we have P is parallel to Q. This is our same setup before. T is the transversal, and we know that it cuts them, and then we label every single angle, right? So our goal is to prove that angle 3 is equal to angle 5. So I'm just going to draw that here. We want to prove that angle 3 is equal to angle 5. That's the goal. And here are some of the things we're going to need. Doop, doop, doop. And the proof gets a little pedantic, but we'll go through it all. Apologies here. It should be. Yep. You're not supposed to get smaller. What's up with that? View, zoom, page width. Sure. Sorry about that. Okay. So we'll start here. You guys can see this. Our first statement is that P is parallel to Q. What's our reason for that? Well, it's given. Good. Our second statement is that angle 3 and angle 6 are supplementary. Wait, angle 3 and angle 6? Why are those supplementary? Let's think about this one. Why in the world might those be supplementary? Oh yeah, it was that other thing that dealt with 3 and 6. Those are, what's that term again? They're same side interior angles. So we're going to use the same side interior angle postulate for that one. Same side. It's going to get me. Okay. Same side interior angles postulate. These things aren't going. Okay. The measure of angle 3 plus the measure of angle 6 equals 180. Let's look at 3 and 6. Oh, those are the same side interior angle postulates again, postulate again. But note that this postulate merely says that they are supplementary. It doesn't say that they add up to 180. This is the definition of supplementary. So it's another step. Angle 5 and angle 6 are a linear pair. Wait, they're a linear pair? 5 and 6. Oh, that it is a linear pair. How do we know that? Well, remember, a linear pair is any pair where we have a line that is intersected or has a ray coming off that forms two more angles. So this is simply an artifact of the diagram. Therefore, we can say it's given. It says, therefore, since these are a linear pair, angle 5 and angle 6 are supplementary. Well, we had a theorem about this, and hopefully you remember what it was called, the linear pair theorem. Finally, measure of angle 5 plus the measure of angle 6 equals 180 degrees. Again, definition supplementary. And then we jump down here. Measure of angle 3 plus the measure of angle 6 equals the measure of angle 5 plus the measure of angle 6. I would accept two answers for this one. But here's the one they're getting at. They're saying that this thing here is equal to this thing. And this thing here is equal to that other thing. So therefore, that first thing is equal to that other thing. What property of equality is that? They use substitution. I was going to say transitive. Book. Often they'll put transitive property in and I'll accept substitution. This time they put substitution and I would have accepted transitive. I thought that's what they were going for. Fortunately, because this equals a single thing, we can just substitute that out, swap it out. These are pretty interchangeable. And finally, since we know that measure of angle 3 plus measure of angle 6 equals measure of angle 5 plus measure of angle 6, what allows us, let me erase these. What allows us to just say, oh, let's get rid of both of these 6's here? Well, that's the subtrahend subtraction property of equality. Cool. So that allowed us to go all the way from saying just that these things are parallel, using all of our properties, one more given here, and finally come up with angle 3 being equal to angle 5. Cool. We have proven the alternate interior angles theorem. Good job. Okay, the corresponding angles theorem. Corresponding angles, same deal. Corresponding angles theorem states if two parallel lines are cut by a transversal, then pairs of corresponding angles are equal. Okay, so here's a pair of corresponding angles. I have angle 1 and angle 5, right? Those correspond because they're both in the same part of that, these intersections, basically. So the proof here, we're not going to do the same formal proof. They're just going to go through it logically instead of doing the 2 columns thing. But here we want to prove that the measure of angle 4 is equal to the measure of angle 8. We can use all of our previous known postulates and theorems and stuff. The first one, they say, by the given statement, we know that P is parallel to Q, given. Angle 4 and angle 6, so angle 4 and angle 6. Angle 4 and angle 6 form a pair of, what are these? What are these again? Alternate interior angles. Good, 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 good. So using the alternate interior angle theorem, we can say that they're equal. It says 6 and 8 form a pair of vertical angles. Remember vertical angles? They're opposite each other, so this is 6 and 8. So we can say that those ones are also equal to each other. Therefore, since 4 is equal to 6 and 6 is equal to 8, we can say that 4 is equal to 8. Again, transitive or substitution. Apparently I picked the wrong one. Since they're equal, we can substitute them out, and we get, finally, measure of angle 4 equals the measure of angle 8. Cool. We got that one. Okay, let's do a couple like problems in the book of some examples. So in this one, we just have to find the value. In the diagram, roads A and B are parallel. So we have, let's see, road A, road B, and then there's a transversal. And they give points here. So instead of naming the angles with numbers, we just have to name them with the 3-letter rule, right? If we want to name this angle, we have to call it point QRP or angle QRP or angle PRQ. However we name it, R needs to be in the middle. This one says it is given that measure of angle PRS equals 9x. Okay, so that's that one here. PRS equals 9x. Good, it's labeled. And measure of angle WUV is equal to 22x plus 25. So this one here is 22x plus 25. And we need to find the measure of WUV. WUV. So we need to actually find out what that is, right? How are we going to do this? We're going to set these, can we just set these equal to each other? Well, no, it's a little more complicated than that. We have to come up with an equation with x, solve for x, and then plug it in, right? We know that PRS, so that'd be this one here, boink, and RUW, this one here, are, what are these? These are corresponding angles, right? So therefore, they are equal to each other. I know that RUW, so RUW, and either VUW or WUV, either way, they're going for this one here. WUV are supplementary angles because they're a linear pair, right? So therefore, if we add RUW, so RUW, this blue one, plus WUV, you'll get 180. Okay, so that means we can plug in our values. We can say that 9x yeah, it should be 9x. Why did they skip this step? I don't know. So we have 9x plus 22x plus 25 equals 180. And then they combine the 9 and the 22 to give us 31. So they didn't include that step. So we know that this is equal to 180, so therefore x is equal to We can algebra it out, but it comes out to 5. You plug 5 in, and you get 5 times 22 plus 25 is 135. Cool. See if you can do number 7. We'll go through it here in a second. But yeah, number 7. Pause. Okay. Number 7 says, in the diagram of a gate, the horizontal bars are parallel to the vertical bars, and the vertical bars are parallel. Find x and y. Name the postulates and/or theorems you use to find these values. So this one's pretty tricky. The 3x plus 2y is referring to this angle here. Boop. And this 126 is referring to this angle. This 12x plus 2y is referring to this angle here. Again, hard to say. And this 36 refers to this angle. So if we want to solve for, let me make this one super hard. If we want to solve for this, we need to come up with 2 equations, right? Because we have both x and y in both of these. So we need to set it up some way to get those 2. So think of it this way. Think of this as one parallel guy. This is one parallel guy. And then this is our transversal. Okay, so that allows us to say that this one and this one are what? They're alternate interior angles. So are they congruent? Yes, we can set up 36 equal to 3x plus 2y. So that's one of ours. 36 degrees equals 3x plus 2y. And then, let me erase this for a sec. Let's look at our other angles. We were supposed to look at this angle here and this angle here. Well, for that one, I'm going to look at this line and this line being cut by this transversal. These are corresponding angles. So therefore, again, we can say 126 is equal to 12x plus 2y. So that's where they get these equations here. Is 12x plus 2y equals 126, and 3x plus 2y equals 36. I'll do a separate video on how to solve this using algebra, but just know that that is a skill that you should have learned in algebra class, and we will come up with it a few times, and it may come up on a future test. Okay, cool. That's all I got for you. Have a good night.